Hi, everybody. What comes next after proving triangles congruent? That's what we're going to find out today. So it's going to be like a buy three, get three free deal. You know, three things in order to prove triangles congruent, and then that's going to tell you three more things for free. The vocabulary word that defines those three things that you get for free is this term CPCTC that we're going to use. It stands for corresponding parts of congruent triangles are congruent. So I'm going to write that down. Corresponding parts. That might mean corresponding segments, and it might mean corresponding angles of congruent triangles. So you have to prove the triangle's congruent before you can use this new thing. Are congruent. Okay, let's take a minute to look at what that actually means. So here's an example that looks a little something like what we've been practicing. There's some givens. We're going to mark it on a diagram, and then we're going to determine which triangles we can prove congruent. So TV, BV, tick, tick. SV bisects angle TVB. I'm going to focus in at the middle letter, and I'm going to bisect that angle at the V. Then don't forget about the reflexive side. I'm going to put a couple ticks on that too. So I can name the first triangle however I want. I'm going to go with STV, which means I have to name the other triangle SBV so that everything all lines up to each other. So which triangle shortcut is that? Remember, our choices are side, 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 angle, angle, and angle, angle, side. So this one is side, angle, side. All right. Then there's a follow-up step. So now we're not going to be done. We're going to go one step farther. So we have our three things which allowed us to prove the triangle's congruent. There's three more things that aren't marked. And now, because we know that the triangles are congruent, we know that all of their corresponding parts would be congruent also. So our angle T and angle B, corresponding angles that come from those congruent triangles? Yes. So we can say that they are congruent by CPCTC. Let's try another example. Angle D is congruent to angle C, arc, arc. Segment DE is congruent to segment CE, tick, tick. Then I need to also show that the vertical angles are congruent to each other. So arc, arc. So what triangles can I prove congruent? Well, I can name the first one whatever I want, triangle ADE. And then the second one, I need to make sure that I go in the same order and line up the corresponding parts. So ADE corresponds with BCE. All right, which shortcut is this? I have two pairs of congruent angles with the segments in between them congruent. So that's ASA. All right, what are we going to want to prove congruent by CPCTC? Well, this is kind of interesting because this one goes one step further. So let's take a look at what we're going to be proving eventually. DB and AC are congruent to each other. Interestingly enough, those actually aren't segments in the triangles, but it's two segments put together. So we have the little segments, CE and DE, that already have tick marks, and then we're going to need these bigger segments, AE and BE. So that's actually what we're going to want to prove next. So AE and BE are corresponding segments from those congruent triangles. So that's CPCTC. So why would those whole highlighted segments be congruent? Well, it's because we're adding two congruent segments together to make two bigger congruent segments. So we could actually call that the addition property. Let's try one more. Oh, we have a problem in a circle. We haven't looked at a lot of these yet. If you have something in a circle, it's probably because we're going to want to show that there are radii that are congruent to each other. So KD and LD are radii in a circle. Angle 1 and angle 2, well, those seem like they come from two totally different triangles. But the interesting thing about that is that means that that little triangle, KML, must be isosceles because it has two congruent angles. So that will actually tell us that the legs in that isosceles triangle are congruent, KM and LM. So that was the whole point probably of that given statement being given to us. That's only two matches, so we need one more thing. and we have a reflexive segment. So I think the triangles that we're going to be looking at are probably these two triangles. So we can say DM is congruent to itself by the reflexive property. So I just proved that triangle DMK is congruent to triangle DML by side, side, side. So how does that help us to prove that angle DKM is congruent to angle DLM? Well, are those two angles part of our congruent triangles? Yes, they are. Angle DKM is this one and DLM is this one. So they are corresponding angles from our congruent triangles. So we can just use the reason CPCTC. All right, let me know what questions you have and we'll keep practicing until we master it. Bye.